Why do you say that this will be the decade of agents and not the year of agents?
Well, first of all, thank you for having me here. I'm excited to be here. So the quote that you've just mentioned, it's the decade of agents. That's actually a reaction to an pre-existing quote, I should say, where I think some of the labs, I'm not actually sure who said this, but they were alluding to this being the year of agents with respect to LLMs and how they were going to evolve. And I think I was triggered by that because I feel like there's some over-predictions going on in the industry. Yeah. And in my mind, this is really a lot more accurately described as the decade of agents. Yeah. And we have some very early agents that are actually like extremely impressive and that I use daily, Claude and Codex and so on. But I still feel like there's so much work to be done. And so I think my reaction is like, we'll be working with these things for a decade. They're going to get better and it's going to be wonderful. But I think I was just reacting to the timelines, I suppose, of the implication.
And what do you think will take a decade to accomplish? What are the bottlenecks?
Well, actually make it work. So in my mind, I mean, when you're talking about an agent, I guess, or what the labs have in mind and what maybe I have in mind as well, is you should think of it almost like an employee or like an intern that you would hire to work with you. So for example, you work with some employees here. Yeah. When would you prefer to have an agent like Claude or Codex do that work? Like currently, of course, they can't. What would it take for them to be able to do that? Why don't you do it today? Yeah. And the reason you don't do it today is because they just don't work. So like they don't have enough intelligence, they're not multimodal enough, they can't do computer use and all this kind of stuff. And they don't do a lot of the things that you've alluded to earlier. You know, they don't have continual learning. You can't just tell them something and they'll remember it. Yeah. And they're just cognitively lacking and it's just not working. And I just think that it will take about a decade to work through all of those issues.
Interesting. So as a professional podcaster and a viewer of AI from afar, it's sort of easy to identify for me, like, oh, here's what's lacking. Continual learning is lacking or multimodality is lacking. But I don't really have a good way of trying to put a timeline on it. Mm-hmm. Like if somebody's like, how long will continual learning take? There's no like prior I have about like, this is a project that should take 5 years, 10 years, 50 years. Mm-hmm. Why a decade? Why not 1 year? Why not 50 years?
I guess this is where you get into like a bit of, I guess, my own intuition a little bit. And also just kind of doing a bit of an extrapolation with respect to my own experience in the field, right? So I guess I've been in AI for almost 2 decades. I mean, it's going to be maybe 15 years or so, not that long. You had Richard Sutton here, who was around, of course, for much longer. But I do have about 15 years of experience of people making predictions, of seeing how they actually turned out. And also I was in the industry for a while and I was in research and I worked in the industry for a while. So I guess I kind of have just a general intuition that I have left from that. And I feel like the problems are tractable. They're surmountable. Yeah. But they're still difficult. And if I just average it out, it just kind of feels like a decade, I guess, to me.
This is actually quite interesting. I want to hear not only the history, but what people in the room felt was about to happen at various different breakthrough moments. Like, what were the ways in which their feelings were either overly pessimistic or overly optimistic? Yeah. Maybe should we just go through each of them one by one?
I mean, that's a giant question because, of course, you're talking about 15 years of stuff that happened. I mean, AI is actually like so wonderful because there have been a number of, I would say, seismic shifts. Yeah. That were like the entire field has sort of like suddenly looked a different way, right? And I guess I've maybe lived through 2 or 3 of those. Yeah. And I still think there will continue to be some because they come with some kind of like almost surprising regularity. Well, when my career began, of course, like when I started to work on deep learning, when I became interested in deep learning, this was just kind of like by chance of being right next to Jeff Hinton at the University of Toronto. And Jeff Hinton, of course, is kind of like the godfather figure of AI. And he was training all these neural networks, and I thought it was incredible and interesting. But this was not like the main thing that everyone in AI was doing by far. Yeah. This was a niche little subject on the side. That's kind of maybe like the first like dramatic sort of seismic shift that came with the AlexNet and so on. I would say like AlexNet sort of reoriented everyone, and everyone started to train neural networks. But it was still like very like per specific task. Yeah. So maybe I have an image classifier or I have a neural machine translator or something like that. And people became very slowly actually interested in basically kind of agents, I would say. And people started to think, okay, well, maybe we have a check mark next to the visual cortex or something like that. But what about the other parts of the brain? And how can we get an actual like full agent or a full entity that can actually interact in the world? And I would say the Atari sort of deep reinforcement learning shift in 2013 or so was part of that early effort of agents in my mind, because it was an attempt to try to get agents that not just perceive the world, but also take actions and interact and get rewards from environments. And at the time, this was Atari games, right? And I kind of feel like that was a misstep, actually. And it was a misstep that actually even the early OpenAI that I was a part of course, kind of adopted, because at that time, the zeitgeist was reinforcement learning environments, games, game playing, beat games, get lots of different types of games, and OpenAI was doing a lot of that. So that was maybe like another like prominent part of, I would say, AI, where maybe for 2 or 3 or 4 years, everyone was doing reinforcement learning on games. And basically that was a little bit of a misstep. And what I was trying to do at OpenAI actually is like, I was always a little bit suspicious of games as being like this thing that would actually lead to AGI, because in my mind, you want something like an accountant or like something that's actually interacting with the real world. And I just didn't see how games kind of like add up to it. And so my project at OpenAI, for example, was within the scope of the Universe project on an agent that was using keyboard and mouse to operate web pages. And I really wanted to have something that like interacts with, the actual digital world that can do knowledge work. And it just so turns out that this was extremely early, way too early. So early that we shouldn't have been working on that, because if you're just stumbling your way around and keyboard mashing and mouse clicking and trying to get rewards in these environments, your reward is too sparse and you just won't learn, and you're going to burn a forest computing, and you're never actually going to get something off the ground. And so what you're missing is this power of representation in the neural network.
Yeah.
And so, for example, today people are training those computer using agents, but they're doing it on top of a large language model. And so you actually have to get the language model first. You have to get the representations first. And you have to do that by all the pre-training and all the LLM stuff. So I kind of feel like maybe, loosely speaking, it was like people keep maybe trying to get the full thing too early a few times, where people like really try to go after agents too early, I would say. And that was Atari and Universe, and even my own experience. And you actually have to do some things first before you sort of get to those agents. And maybe now the agents are a lot more competent, but maybe we're still missing sort of some parts of that stack. But I would say maybe those are like the 3 like major buckets of what people were doing: training neural nets per tasks, trying to the first round of agents, and then maybe the LLMs and actually seeking the representation power of the neural